Hey guys, and welcome back to another YouTube video. This video I will teach you how you can create a neural network in Python from scratch that classifies the images of scientists. The two scientists that I chose for this task was R. Schrodinger and Stephen Hawking. So I've opened up a Jupyter lab and I think I'm just gonna go to the light theme real quick. Yeah. So I'm gonna make a comment imports. As always, we'll be using TensorFlow. Then from TensorFlow import Keras, import OS. Then from matplot, okay, matplotlib import pyplot as ELT. Then from TensorFlow.keras.preprocessing.image import image data generator, and from TensorFlow.keras.pre, actually I'm just gonna copy paste this, import image. So these are the imports. I'm pretty much sure we're not gonna be importing any more things. Okay, let me just run this code block real quick. Now doing the data preparation. So we need to get a training image. And grab the image data generator property, and we need to grab the rescale property of it and divide it by 255.0, and let's just run the program. Now making the training dataset. So train underscore dataset is equals to the train underscore image dot flow underscore from underscore directory, and the flow from directory will be applied, so I need to place in like the path. So copy path, not open up my launchpad, paste the path. Now I need to specify the target underscore size as 200 by 200. I need to specify the batch underscore size as 1, and the class mode of a binary. Since we are dealing with only like two label classification, I'm choosing binary, otherwise I would choose categorical. So let's just run the program. So we get it, found 20 images belonging to two classes. So now getting the class indices. So let's just type out print train dataset dot class underscore indices. So we get Erwin Schrodinger as 0 and Stephen Hawking as 1. So I'm just going to copy that, and I will just make it as a comment. So we get it as a dictionary. So now making the model. The step out model is equals to keras dot sequential, and it will be a convolutionary neural network. So keras dot layers dot con2d 64 kernel size with a 3x3 filter and an activation function of ReLU or a rectified linear unit. And and let's pass it through another convolutionary layer. Actually, I'm just going to pass it through a max pooling with a pool size of 2 by 2, and let's just pass it through another convolutionary layer with a 32 kernel and a 3 by 3 filter and a activation function of a gain value. Now we will pass it through a flatten layer. So keras dot layers dot flatten, and now we will finally pass it through the output layer. So keras dot layers dot dense, and with a 2 neuron output and an activation function of softmax. So now I will compile and fit the model. So I'm just going to make a comment compiling the model. So I'll just about model.compile with the optimizer of Adam, and the loss function will be sparse underscore category coracle underscore cross entropy, and the metrics that our model will optimize on will be the accuracy of the model, fitting the model. So I'll just call the model dot fit on this on the train underscore dataset, and the epochs will be 10. So let's just run this file. So we are on our epochs. So I'm just going to make a comment getting the summary on the model. So I'm just going to type out model.summary. So we just type out model.summary to get the summary on the model. It's a very simple command. As you can see, we are running on 100% accuracy, but you can see the loss is increased. The lowest loss, as we can see, is on 1.5% of a loss. So I'm gonna reduce my epochs to about 7 epochs. I'm gonna put like 7 epochs over here. I think we will get a good accuracy if we do that. Okay, I think we are running on a very high accuracy from the start only. That's a good sign. We are not having a lot of loss, so that is something that is certainly something that we want in a model. So we are running about a 3.1% of a loss. So I think we are not able to decrease our loss, but it's okay because we at least have a 100% accurate model, and that's what we really want. So on getting a summary on the model, we have 622,434 training parameters. Since we haven't added a batch normalization to the convolutional neural network that we have made, we really haven't got any untrainable parameters till now. But if we will be adding some batch normalizations to this, we will obviously be getting more and more untrainable parameters. Now we are going to be getting the predictions that the model will make. Now getting the predictions that the model makes is a little bit tricky. It's not the thing that we always do. Since the predictions, we also need to display the images of the predictions, it usually gets a little tricky. So to do that, we will be making the use of the OS module of Python. You don't need to install the module like on your PC. It comes pre-installed with all your Python versions, so that's something good. So yeah, so that is what we are going to be making use of. So what we need to first do is specifying the path to the directory containing the testing images. So I'm just going to type out dir underscore path is equals to, and over here I will specify the path to the directory. So you can see I've created a folder called scientist testing with no subfolders in it, I'll just click on the command copy path, and now you simply need to paste the path over here. In Windows you will fix the slashes, but on Mac it is like this only. So now we are going to be actually we are going to be listing the images and listing the images. So we type out for I in os.list dir, so it will list all of the directories and the images inside it, and then we have to pass in the dir path. And then what we do is use it, and now we are using matplotlib to show the images. So that's what we are going to be doing is type out image is equals to image dot load underscore image img, I'm sorry, and image is basically the module that we had imported up top over here. Now I think when you are using the image module, we need to be having the PIL or the pillar module of Python installed. So if you do not have that module installed till now, you need to install it, because otherwise it will not work. So go to your terminal and just go type out pip3 install pillow, and it will install it up for you. So in case if you are running into any error, then I think that will be the error. So image.load image, and we need to pass in the dir path, so dir underscore path, and then we have to pass in a slash slash, like we're separating each image with that slash, and then we put a plus and put the index of the image, and then we have to pass in the target size that we want each image to be. So as we all know, the target size will be 200 by 200, because that's what we have resized the images to. In case if you have resized the images to any other target size, that's what you will be specifying over here. Then we just type out plt.im show the image, and then we just call the plt.show method on this, so it will show all of the images and not like stop by just showing one image. Now we are just going to be adding the images to an array. So that's what we are going to be doing, that using numpy. So I think we have imported numpy also up top over here. Okay, we haven't imported numpy, so I'm just going to import numpy up top. So import numpy as np. So I'm just going to run this code block again. So now that we have imported numpy, we will be able to use numpy over here. So I'll just type out x is equals to, and we will convert this to an array. So image.img underscore to underscore array, and we will pass in the image over here. Then we will need to expand the dimensions of the array. So x is equals to np.expand underscore dimes, and then we put in the x and we give it an axis. So the axis will be 0. Now this is just some basic numpy syntax. I'm not going to be going and explaining you numpy, because this is a TensorFlow tutorial. So images is equals to np.vstack. So we vertically, like, we stack the images in that array, and that's what we are basically doing over here. Now we are going to make another comment redirecting the images. So I will just type call out val is equals to model.redirect, and we need to pass the images to the final variable that we have defined over here. And then now look what we do. I will type out if round val of the 0th row, like the 0th thing and the 0th index, because this is an array, so we are referring the first part of the array. So it's like, if you were to ask me something like in this, it's like something like this and this. So in this we are referring to the first one, and from that also we are referring to the first thing. So that's what we are doing, is equals to 0. Then I'm going to print out what we are going to print out, Erwin Schrodinger. So I'll print out Erwin Schrodinger. I know I misspelled Schrodinger, but like the O has that two things which I don't know how to make. And if the rounded of the val of the zeroth and the zeroth is equals to a 1, then what we want to do is print out Stephen Hawking. And that's pretty much the entire model that we wanted to make. Okay, invalid syntax. Okay, it's not is, it's OS. Okay, done. So you can see it's printed Stephen Hawking, Erwin Schrodinger, Stephen Hawking, Erwin Schrodinger, Erwin Schrodinger. Okay, so it's like not very good at predicting. It's okay at predicting. So we can definitely make it better by improving the model. So I think I don't know if it will actually improve the model, but I'm just trying it out. I will add another max pooling 2D. So I'll be back in a second, guys. Okay, so just a quick break. So I'm just going to add this another max pooling layer, and let's see if it improves the accuracy that our model is having. So I'm just gonna make the epochs 10 again. I think we will be able to get a good one. Okay. Now, if you want the training to be very fast, because if you are running on like a slow machine, like a very slow machine, and it's not like the training process is taking a lot of time, and not the small but any other model, then you can add something called a steps underscore per underscore epoch and give it something like 3 5. The lesser you give, the more epochs you need to run, because the accuracy will like what the steps per epoch does is that it will look at the accuracy and it will stop the epoch from running once it reaches to a certain threshold of the accuracy. So if you want to do that, you can certainly add a steps per epoch. That is certainly something very good, but I don't really like to add that. So you can see we have run to the 10 epochs and we have got a really good accuracy with just a 3.5% loss, which is certainly something very good. So on running the thing again, let's just see if we can get a good predictions. So the last label that you are seeing, which always is like something. So Erwin Schrodinger stands for the first thing. I don't know why there's this thing. So we need to do. So instead of doing that, what I'm going to do is also do something like this. PLT dot title as Erwin Schrodinger. So I think that will should do something nicely. And PLT dot title Stephen Hawking. Good. Let's just run this again. So that is Stephen Hawking. That is predicted as Erwin Schrodinger. Stephen Hawking. Okay, this was incorrect. Erwin Schrodinger, Stephen Hawking, that's incorrect. Stephen Hawking and Erwin Schrodinger. So that Erwin Schrodinger is basically like this image, but I don't know why. Sometimes this gets messed up. But you still get the point. A model is almost getting every single image correct. You can also evaluate the model if you want, but I haven't really created any testing data because the data we made was just like 10 to 20 images. So it did not really matter if I made any validation or evaluation images. Obviously, if you want, you can surely go ahead and customize this model if you like want, whatever. So this was the entire model. It was a not that complicated, but we certainly made a really good model. I am very happy with the model that we made. Also, this was a pretty cool trick on getting the summary on the model in case if you want to know the total number of training parameters. If you want that there are some non-trainable parameters in the model, you can certainly go ahead and add a keras.layers.batch normalization layer. But I don't really add that in this model. Like you could surely add it, but I didn't want to add it because we already were running like two convolutionary layers with the max pooling with each, and we also were passing it through a flattened layer, and the model was looking pretty neat. So we didn't really need to add it, but in certain areas you would probably want to put certain things like a batch normalization or an average pooling or something like this. So we trained the model really, really nicely, and this was a very good and a successful model that we made. Yeah, actually sometimes it can get the images incorrectly, but you know, still it was a pretty good model, and I think you would have taken some value from this video and put it in some other machine learning or neural network video of yourself. So that's it for today, guys. I hope you enjoyed the video. If you did, like and subscribe to the channel, and I will see you in another YouTube video.